Hello everyone, welcome back to our second part of our Blender Geometry Notes Rubik Cube project. In the first part, we created the basic Rubik Cube structure procedurally. We used a cube node, instance on points, smaller cube pieces, face index values, position comparison and rotate instances to rotate only one selected layer. But we also discovered an important problem. When we rotate one axis first and then try to rotate another axis, the rotation logic starts breaking. This happens because a simple rotation setup does not properly remember the previous state of the cube pieces. So in the second part, we are going to move one level deeper. Today, we will introduce simulation node in Geometry Nodes. Simulation allows Blender to remember values over time, and this is very important when we want to create a system that behaves more like a real Rubik cube. We will learn how to store rotation values using named attributes, almost like variables in programming language. We will create values such as a new rotation value and old rotation value and difference rotation. Then we will calculate how much the cube layer should rotate only when the input value changes. After that, we will use a map range node to convert simple input values into precise rotational values. This will help us rotate the Rubik cube layer accurately at 90-degree angles. Finally, we will organize the entire rotation logic into a reusable node group, expose useful controls like side index and rotation value, and prepare the setup so that the same logic can be later be expanded to all the 6 sides of the cube. So this episode is not just about adding more nodes, it is about understanding how logic, memory, variables and controlled movement work inside a procedural system. Let us open the saved Blender file from part 1 and continue building our Rubik cube simulation using Geometry Nodes. I will start by launching Blender. I will double click on this shortcut to launch Blender. I have the latest Blender 5.1.2 version, and in the previous session I had saved this 01 Rubik cube.blend file. So if you are continuing from the previous session, you open this saved file, or if you doesn't have this file, in the YouTube video description or in the e-learning page I have provided you a Patreon link. If you go into the Patreon link, you can download this file and start working in this session. So I will just click to open. I am already in the Geometry Nodes layout. I will middle mouse click and pan in my Geometry Layouts window. I am going to add a simulation to my rotate instance. To add simulation, I will just press Shift A and in search, I am going to type simulation. So you have simulation. I will just select this simulation, and when you select simulation, you can see simulation has geometry input with delta time. It has an output. I will bring this rotate instance in between this. I am going to disconnect connection coming to rotate instances. It is coming from my instance on point. I will drag it and connect it to the simulation input. I will geometry output. I will disconnect this. I will drag this geometry output and I will connect to this simulation output. Inside this simulation output, I am going to drag this simulation from here and connect it to instances, and from instances I am going to connect it to the geometry. Now this rotate instances, I have placed it inside the simulation. I will come into Z and I will just type 1. So it is going to rotate 1 degree. Now I will go to file, save it, and now if I play, you can see selected index, that is index 0, is rotating continuously. So this is creating an animation where for every frame it is getting rotated by 1 degree. I will stop the playback and I will rewind it so that I am in frame number 1. I somehow want to save the rotation values. To save this rotation value, I will just drag this left simulation a little to the left. I will make some space here. I'll press Shift A and in search, I am going to search for store named attribute. Select this and this is going to store an attribute just like you store values in a variable. I will set its value to float, and instead of point, here I am going to select instance and I am going to call this as new underscore ROT. It means that new rotation, and I will drag it and place it between the input and rotate instance. I have placed my first stored name attribute here. So this is a new rotation. I am going to select this stored attribute, press Shift D to duplicate it. I will drag it to the side and place it. So as soon as I place it, it automatically got connected. I leave everything as it is, but I am now going to call this as diff underscore. Now I will again select the second stored attribute, press Shift D and drag it next here. If I just move the simulation and rotate instance here, I want to place it in between here. I have the third store name attribute added here. I am going to call this as old underscore rotation. I am recording three variable values. First we call it as the new rotation, next is the different rotation, and third is the old rotation. So what we have done here is we have created three variables, new rote, diff underscore rote and old underscore rote. Once variable is declared using store named attributes, we have to call this variable, and to call this variable, the node we are going to use is named attribute. Press Shift A and in search I will search for named attribute. I will keep the named attribute below, and in the first named attribute, in the name column, if I just click, you can see all variables that we have declared, and one of the variable is new underscore ROT. I will select this. So I have called one variable now. I will press Shift plus D and duplicate it, and in the second case, I will click on this name column and I will select old rote. So I have called one new rote and one old rote, and I have to subtract this new rotation from old rotation. So for that, I will press Shift A and in search, I will search for the add node, math add, and in this add node, I will change this add to subtract. For the value 1, I will attach the attribute coming from new rote, and for the second value, I will connect the attribute coming from old rote. And whatever result I am getting from this entire calculation, from these three nodes, I will select all the three by putting a box, slightly drag it to the side. I will connect this to the diff underscore rote. I will make a copy of this named rote. I will select named attribute, press Shift D, make a copy, and I will attach this new underscore rote variable to the value of my old rote. So now exactly what is happening is, as soon as the rotation starts here, it has a new rotation value. I am taking this new rotation value minusing from old rotation value. So now what happens is, this difference rotation value will be 0. For this 0, I can add my own value in this value field. From this, we are calculating this one value, diff underscore rot, and this value I have to apply it to the rotation. Instead of applying directly the z value to 1 degree here, I will make this 0. This z value I have to get it from this diff underscore ROT variable. So for that, I have to first separate this xyz value and apply diff underscore rot only to z. For this purpose, I will press Shift A and come into search, and I am going to select a node called as combine xyz. So when I click on this combine xyz, its output is a vector. I will drag it and connect it to the rotation vector of my rotate instance. The rotation values of x, y, z can be controlled separately. So I have these three nodes here. Now I will select the name attribute, press Shift D to duplicate and place it at the bottom. And for this, I am now going to call the diff underscore rot. So now when I set now I will connect diff underscore rot attribute to z. If I rewind and play it, see, as of now, no rotation is happening. But when I click on this value, see, every time I click it, see, now as I click here, the rotation is going. Only when the value in my new underscore rot changes, it is going to rotate. However, I cannot precisely control this rotation. So to precisely control this rotation, I am going to calculate this value by using another node called as map range. In this new underscore rot store named attribute, this value I am going to calculate it using a mathematical calculation. So for that, I will set this value back to 0. On the left hand side, I will just pan by clicking the middle mouse, press Shift A and in search, I will search for map range. And this map range in 2 max, and I will set this value into 2 star Shift plus 8. I will multiply it by pi. And if I press enter, the 2 pi value is 6.283. Why are we using pi? Now we are using this 2 pi to give an exact precise quarter turn rotation. By setting this value to 6.283 and then here on the top from maximum, I will set this value to 32 and from minimum to minimum will be set to 0 only. By changing this value, what happens is for every 8 value, this is going to exactly rotate by 90 degree. A Rubik cube layer usually rotates in 90 degree steps. Since 2 pi radians is a full 360 degree turn, I am going to get 8 exact steps to correctly rotate it by 90 degree. So this mathematical calculation I am doing it in the map range, set from minimum to 0 and from maximum to 32. 2 minimum is set to 0 and 2 maximum is set to 6.283. Now I will drag this result and connect it to the value over here. I will go to file and save the file. I will rewind. See, the value is currently set to 1 and you are seeing a small rotation. If I play and if I change this value to 2, see the rotation. Then I will change it to 3. I will change it to 6. And exactly when this value becomes 8, this has correctly rotated by 90 degrees. So I will stop the playback and set this value back to 0. Now as we are building this logic, you can see that our node structure is becoming highly complicated. We have so many nodes here. To show you better, I will make this geometry nodes panel full screen, and for that bring the mouse into the panel and press Ctrl plus space. It becomes full screen. And if I now zoom out, so already we have so many nodes and it is now time to correctly organize it. So for this organization, I will just drag a box and select this simulation output and group output and drag it to the right. I will make more room here. I will now drag this group instances. I will drag this 3 stored named variables and place it next, and I will select this top selection making process where I am going to select the exact layer of my Rubik cube. I will drag it and place it to the side. This map node is left out here. I will drag it and put it at the bottom here so that I have this simulation input, simulation output, and all the calculations that we have done in between. I will just click and drag a box and I am going to select all these nodes together and I am going to just press on my keyboard Ctrl plus G, and now this entire thing has changed into a group. You can see here node group. And if I come back to Rubik cube, you can now see that this entire section has changed into a group. See, this has been organized correctly. So I can just drag this simulation back. And to open this, if I just double click it, you can see this opens in a tab and you have this complete grouped node under this node group. And from this entire node group, I need 2 values. One is the axis, whether I have to rotate my Rubik cube first set, second set or third set we were controlling it from this sample index, this index. So when I change this index, the selection is going to change. So I'm just going to drag it and put it to this group input. Other value I require is the rotation value, and the rotation value is coming from this map range. I will take this value and drag it to this group input, and you can see two values are created here. So for me to understand it better, I have to rename this. So to rename it, I will select group input, and if you press N on your keyboard or if you press this left arrow, you will have this group panel open here. And here I will come into the index. So I will select this index, press F2, and I am going to call this as side index. And then for the second value, I will select it, press F2, and I am going to call this as rotation value. So, and you can see here, this group input has two inputs, side index and rotation value. For this entire node group, I am going to call this as Z axis, because in this case, we are doing the rotation along the Z axis. Setting these values, I will come back into Rubik cube, and now you can see you have Z axis, you have the side index and rotation value set. I will press Control space to minimize this geometry nodes panel. Now I will go to file, save it. I will rewind it. Now I will play it, and in the rotation value, when I change it, you can see it is changing. If I set it to 4, it is rotated exactly by 45 degree. Now the side index indicates, and now I will change the index value. The index value is currently set to 0. So I will stop the playback, rewind it, and if I set the index value to 1 and if I play it, you can now see the middle layer is getting rotated. So I will stop and rewind, and if I change this index value to 2, you can see the top layer is changing. So I am controlling which layer has to rotate using the side index and the rotation value using this rotation. All this we have done to control just one rotation. We need multiple rotations. So in a Rubik cube, I have 3 rotations along the z-axis and 3 rotations along the y-axis. For every rotation, the variables that I have declared in this, the name has to change. So I have to tweak this z-axis group a little. I have to replicate it 5 times so that I have 6 axes here, and using that 6 axes, I can control the various rotation layers. Now come into File, choose Save As and give it the name as 2_Rubik Cube and click on the Save button. Let us meet in our next session to continue with applying the same logic to all the 6 axes.